computer. Okay, so I have a rectangular prism that has a base that is 15 by 12 centimeters and a height that is 20 centimeters, right? So it's going to draw that. I have my rectangular prism. How do I draw a rectangular prism? I draw a rectangle. I do 4 small slanted lines. Let's say 3 small slanted lines. No, I lied, 4 of them. And I just connect them, right? There, I have a rectangular prism. So I have a base that is, so first off, where do I put the 15? Do I put it like on this little part here, or do I put it over here? Or does it not matter?
It says 15 centimeters by 12.
By 12, right? But the 15, which way does the 15 go to?
I think like if it's a rectangle and like by 12, it's like
It's 15
like
by
there, and then right there by 12, and then the slant right there, I think that is 20 centimeters.
Well, so
it would be bigger, so no.
well, so don't go by what the graph looks like, right? Don't go by what it looks like. Like, because I just randomly drew this, right? I could have.
Well, so it's like a wonky rectangle.
Well,
Wouldn't it be like 15 by 12 centimeters?
15 by 12. It's closer to, well, yeah, about 15 times 12. But so in this case, it doesn't matter where I put the 15 as long as it's connected to the base. I could put the 15 at the bottom, or
Isn't the height like this?
the height is straight up. Yeah, yeah. So the 15, I could put it on this bottom one here, or I could put it on this little slant. It doesn't matter as long as the 12 goes in the other spot, right? The base is 15 centimeters by 12 centimeters. That's all that matters, is I have the base correct based on what it tells me. And then all I need to do is I need to get my height set up properly as well. And it tells me that my height's 20 centimeters.
So it would be like 3600 times 5 or?
So we'll show you here. So the area for the volume here for this prism is going to be the base, area of the base times the height, right? So what's my area of my base here?
20 is 3,000 or 300.
We'll get there. We'll get there. So what I'm going to do to figure this out, I'm just going to write my formula down, right? So, black text. And I'm going to make that a little bit bigger. Can everyone read that okay? You good, Austin? Yeah. Perfect. So remember, it's the volume of the area of the base. How do I find the area of the space? I just take the length times the width, right? Because it's a rectangle. Length times the width times the height now is the final part. So the area of the base, which is also just length times width, times this height, the h there. Oop. All right. So in this case, so my length is going to be, doesn't matter if I pick 15 or 12 in this case, as long as I have the base, as long as I'm picking something from the base there, right? So 15 centimeters times 12 centimeters, and then my height was 20 centimeters. So 15 times 12 times 20, that is going to give me a grand total of 3,600. So in this case, my V is 3,600 centimeters cubed, which is the little 3 here, right? Because you're taking 3 of these centimeters, you're timesing them together.
And that's the area.
That is the volume. This is the volume of it. So this is how much stuff you can fit in that. So if I was to pour water in there, I can fit 3,600 cubic centimeters of water. So to give you an idea, cubic centimeter, so everybody like these little things? That's what this is right here.
This is 750 millimeters.
Yeah.
Right? That's the volume.
That's the volume of it. Yeah. Yeah. So this is a cubic centimeter. So in that container, I can fit 3,600 of this. And again, 1 liter is 1,000 of these things. 1 liter would fit 1,000 of these. So I think Aiden has like a liter jug there. I could fit, 1,000 of these or 100 of these. Or
So you can fit 750 of those in. Like right here.
Yeah.
I don't know. No,
There's no data 650 now.
I'll look it up. Thermal flex.
Well, that's not the main point. I'm just making an example there, right? So
So what is that? 700?
Well, that's what I think it is.
it doesn't matter. It doesn't matter. So
As long as we got the right answer, right?
Yes, so, but not really, it's gonna percent.
yeah, volume is like,
Everything, that was a no.
No, but the container.
guys, it doesn't matter. We're moving on.
1.2 liters.
So, so the next thing that it asks here is it would want us to find the capacity of this prism, right? So this is the volume. Remember, the volume is how much stuff you can fit in that. It's the measure of the space. Because remember, you don't measure liquids, your water bottle, by how many cubic centimeters it fits. Oh, so you don't measure. Focus in, please. So you don't measure how much space something fits in by centimeters, right? You use it by liters or milliliters or gallons, stuff like that, or ounces.
Yeah, you know why you do that easily? You just check alcohol.
Yeah. Well, yeah, we use a frame of reference, right? So, but the capacity is how much it can hold, and that's where we swap it to this liters and gallons. So this question here, it wants you to calculate the capacity of this. So it wants us to turn the centimeters into something that's actually like a liquid form. It wants us to turn into like liters or gallons, right? So how the heck do we do that? Well, one thing we know is that 1,000 centimeters cubed is the same thing as 1 liter. So if 1,000 of them is 1 liter, how much would 3,000 be? 3 liters, right? Or 3,600. And how much would 3,600 be?
Like 3.5.
3.6 liters.
Well, yeah, like 3.5 fish, but no, yeah.
So to turn,
Put it oil in the vehicle.
so to turn to turn a volume into a capacity. So sorry, to turn a volume centimeters cubed. Put a cube there. I'll put that there in a second.
That's what I was wondering. Isn't it like
It's
3,600 centimeters cubed?
Yeah.
Or you could say like cube centimeters.
Yeah, you could say that too. So we turn our volume, which is centimeters cubed. I'll put the 3 there in a second, into a capacity, which is going to be liters or ml, milliliters, right? So
If you do us a favor, you like print out something like
a formula sheet.
yeah.
I will. Yeah. So, so to turn volume into capacity, how I'm going to do that is I'm going to figure out like the base units I'm using. In this case, you're pretty much always going to use centimeters and liters. So centimeters and liters, I'm just going to divide it. If I know that 1 liter, 1 liter is the same thing as 1,000 cubic centimeters, then I would know. First off, we can just look at this and we know that 3.6 liters is the same thing as 3,600 cubic centimeters, right? So in this case, we can just look at it. We might not always be able to look at it, but you really what you're doing is you're just taking this thing here, a centimeter cubed to liters, is you're just dividing this thing by 1,000, right? So all I'm doing is I'm taking my 3,600, I'm dividing that by 1,000. That's technically what you've done here. And then that is going to give you your answer, no matter what that is there. Because it's not always going to be nice, clean numbers.
No, it's
Cubed, cubed. We're dealing with volume. It's always going to be cubed.
velocity is really. That makes sense.
Mhm. Okay. So we're going to keep on going here. We're actually going to skip the first one. This is just an algebra question that we don't really need to worry about right now. So we're actually going to skip that first question and we're going to jump on down to question 2. So what we end up coming into is we're going to come into a composite prism, right? Composite just means it's 2 or more simple shapes added together, right? That's what this is. So there's 2 ways of figuring this out. 1, I could split these apart and add them, or 2, I could extend them, find the area of this volume of this whole thing, and then take it away. Either is fine to do. I'm going to just do the add-in part of it. But you could do it really like either or there, and that would be totally fine.
As long as you show your work.
As long as you show your work, right? As long as it's organized for you. If it makes sense to you, it'll be easier. So how am I going to do this? I'm just going to split these 2 up. And again, you could split it up. Don't draw this yet. You could either split it up like this, by going like cutting it down. Oops. Or you could split it up. We are on page 41, you betcha. Yeah. So you can do this either way. Now, with area, what was the issue with cutting a shape up? What was the issue with surface area when we did this?
The bottom part in. Doesn't need it.
Well, yeah, we have to take away that bottom part, right? Like it's surface area, and this is something that isn't actually like there. But with volume, we don't need to do that. We don't actually need to take stuff away when it comes to area. With surface area, we do. Sorry, with volume, we don't, but with surface area, we do. So because we're finding the volume of this, it's just how much stuff it can fit, right? I don't really care about it. So this imaginary line, I don't need to take it away later. So what I'm going to do is I'm going to figure that out. So I'm going to label it. So this shape right here. Sorry?
You add cube with cube.
Yeah, we'll end up adding that. Yeah. So I'm going to call this shape here just shape 1. I'm going to call the bottom shape down here shape 2. So top one, shape 1, bottom one is shape 2. That's how we're going to do that. Oops. So how do I find the volume of this? All I do is I take the volume of my total thing is going to be the volume of shape 1. Actually, I'm going to just type that, write that, it'll make it a little easier.
So do we have to do all that math?
No, it's a lot less math. It's a lot less math. That's what I was just talking about. So we add just shape 1 and shape 2. So my volume of this is going to be, it's just V1 plus V2, right? Volume of shape 1 plus volume of shape 2. That's how I do it. Remember, always start with a nice simple equation at the start. It helps a lot for those really hard questions. So let's find shape 1. So I'm putting V1 here, right? That means volume of shape 1. We're mathematicians, we're lazy. That's why I'm putting V1. So V1 is just going to be, how do I find the volume of a prism again? Length times width times height, or the base times the height, right? So this is a rectangle. So that's the base is just length times width. So length times width, and then I times it by the height. So I'm going to say that this thing right here is just my length, this little line I made. It doesn't tell me nice and clean, right? It doesn't tell me exactly. Oh, no, it does tell me this right here, 9.4. If it didn't tell me, I'd have to figure it out. But so it's 9.4 centimeters. My width in this case is going to be this. Remember, you're figuring out the base. And I know that this line here is the same as 6.6. If you're ever unsure, you can always take the ruler, make sure the measurements stack up. And then my height of this whole thing of number 1 is going to be 4.2 centimeters.
The whole thing,
Of just V1.
the whole height would be 4.2 plus 7.5.
I'm sorry, I meant a V1, like the whole shape 1.
Oh.
Yeah, yeah. So I have my length, my width, and my height, 9.4 times 6.6 times 4.2 gives me 260.57 centimeters cubed. Okay, I'm halfway done. Next, I figure out the volume of shape 2, which is V2. So in this case, I do my height, I do my length times my width because it's a rectangular prism. So length times width times height. You notice how I'm writing down the formula, right? That helps you like memorize it if you do it that way. So my length in this case.
Is that 9.4 times 6.6?
Times 6.6, yeah. I can make the text bigger if you want. Yeah, for sure. Paste that. And there we go.
Is that centimeters cubed or?
Centimeters cubed, you betcha. Because it's volume. So what I'm going to do is I'm going to take my length, which is 16.8 centimeters, times that by my width, which is going to be 6.6. Remember, you do your base first, then you do the height. And my height in this case is going to be 7.5 centimeters. So 16.8 times, open that up here really quickly. Yeah, so 16.8 times 6.6 times 7.5. Then all I need to do is I just need to calculate those out. 6.6 times 7.5. I calculate all these out. I'm going to end up with 831.6 centimeters cubed. So that's all I need to do there.
Really big number, you actually get the whole number.
Sorry?
If you times 831.6 3 times, like not times 3, but altogether.
Like to the power of 3. Oh, remember, we're not cubing 831. We're just cubing the centimeters, showing that as volume.
Oh,
Yeah. So all I need to do now is remember my original formula, the volume of shape 1 plus the volume of shape 2. I have those now.
so we just have to add it.
You just have to add them, right? So remember, I find this just by doing V1 plus V2, which is just going to give me 1,092.17 centimeters cubed.
Now, are we converting that to meters or anything?
So
It's 70.
I'll get there. I'll get there. So again, I do not take anything away in this case. The question is only right now is asking for the volume. With the volume, just asking how much space it fills. This little invisible line was just for our reference. It's not something I need to take away a little bit later. So now that's part 1 of the question. But remember, always read the question, underline the important stuff. I need to calculate the volume. I also need to figure out the capacity now, right? Volume is how much stuff it can, like how much space there is. It's a unit of measurement. centimeters. But capacity is how much you can like fit into it. That's when it's going like liters, gallons. I need to convert this. How do I convert this again? Divide by 1,000, right? Because 1,000 centimeters cubed is the same thing as just 1 liter. So, so to figure out my capacity, I'm just going to do that right over here below this shape. So capacity, you might want to underline this as well. You know, it keeps you organized, knowing this is volume. This is the second part of the question. So my capacity here is just going to be turn the centimeters into liters. So capacity is just turn the centimeters into liters, and I can do that just by taking 1092.17 and dividing that by 1,000. And what's my answer going to be there?
1.09.
1.092, technically 17 liters. We can go to just like 2 decimal places, right? 1.09 L, which is liters. And that's my other answer. So making sense there? So like it can be easier than surface area for sure, at least with composite shapes. Now you can make it harder, but composite shapes now are a little bit simpler. It's just splitting it, adding them, done. Everyone good to go? Everyone has that written down? Okay, so now what I'm doing is I'm changing it up a little bit because now I'm dealing with a can. Can is a cylinder, right? Can's a cylinder. So it's question 3 here is a can of tomato sauce has a radius of 3.8 centimeters and a height of 10.2. Make sure it says radius and not diameter because those are different, right? We will have to, yeah. So I'll bring that up here in a second. But so in this case, you can draw this if you want. You don't always have to. I'm going to draw just for this. You don't have to if you don't want to. I'll get there. So in this case, it's saying my radius is 3.8 centimeters. And my height is 10.2 centimeters. So remember, the core idea behind volume is I take the base, you could say the top in this case, because like technically the top's the same as the bottom, and I times it by the height. So it's really, so it's the volume of a cylinder is really just the area of this times the height, right? Like just remember that's the core idea behind volume. The base times the height. That's what it is. So how can I figure out the volume of this can? Well, in this case, my volume of this is going to be my formula to find the area of a circle, the base in this case, is pi times pi times r squared, right? Yeah, so pi times r squared. Which is the same thing as, so V equals, I'll write pi here in a second. So it's pi times the radius, which is 3.8 centimeters. Ooh. I'll get there. And now remember, you're squaring the radius here. Oh, sorry, this is also times the height. My bad. And then, so it's pi times radius times height, which is 10.2 centimeters. So even though there's 3 things here, you have to remember that what that squared is attached to. I multiply all this lovely stuff together. 462 point, I'm just gonna put 72 centimeters. I don't care about all those decimal points. We don't need all those decimal points. But now, boom, that's it. That's my volume. So that's how much space it can actually fit in there.
So it's 5,000, so it's 9 meters.
Okay, so I'll give you a second. And yeah, this next question here is how much tomato sauce in liters does the can hold? So now we're in a capacity question, right? In liters. So we need to convert this. You wouldn't say, oh, it fits 462 milliliters. You wouldn't say, oh, it fits 462 liters. So what we would do here is we're going to take our volume, which is 462.72 centimeters cubed, and we're going to divide that by, I'll fill the symbols there in a second. We're going to divide that by 1,000 because we know that 1,000 of these centimeters cubed is the same thing as 1 liter. And then that is going to give me 0.462 liters, which is also the same thing as, in this case, it is 462 milliliters.
Milliliters now?
You don't have to, but just give you an idea.
What if I didn't do all that math, I just did the last
Eventually, you could kind of just throw that straight in there. That would be fine. Yeah.
Well, yeah, just like one question.
Yeah, but I just wanted to show the process here because sometimes we're going to have to mimic this process with something else later, eventually. So either of these is totally fine. Sometimes it might ask you to instead of liters. In this case, it says in liters, right? So this would technically be the correct one, but if it doesn't say, you can put it wherever works best for you, as long as it makes sense to you. Okay, so I want you guys to practice this a little bit here. So give a couple of page 42 an attempt. Except for question 2. Don't worry about question 2.
For rectangular prism, backside the times.
So rectangle. Well, if you're finding the volume, yes. So volume's it's the base times the height. Oh, I'm gonna pause this. Resume recording. So if you're doing question 3 here, where it's in the edges, remember the only measurement we know is that 1,000 cubic centimeters is equal to 1 liter. We don't know how that works with.
321.
I'll get there. I'll get there. So I'll show you why. Normally we just divide the answer by 1,000. Boom, we're done. We can't do that in this case. And I'll show you why in a second. But what I actually need to do is I need to turn each of these inches into centimeters. I need to go to the very start of it. And so one thing that's kind of nice to know is 1 inch equals 2.54 centimeters. So 1 inch is 2.54 centimeters. So all I'm doing is I'm taking these numbers, I'm timesing it by 2.54. Again, you were not expected to get this. That's fine. Normally you'll get told this, but so it's 3.81 inches times 3.75 is, so I'm just converting all these into centimeters. 9 point, oh, sorry, this is supposed to be centimeters over here. I took this number, I times it by, yeah, so I took the inches, I times it by 2.54 because 1 inch is 2.54 centimeters. So all I'm doing is I'm converting the inches into centimeters.
How did you times that if you're dividing?
Sorry?
You said 2.25 inches, right?
2.54 inches.
Is
So how do you all have them up?
3.81 centimeters.
So 1.5 inches is 3.81 centimeters. Yeah.
Oh,
Yeah.
oh, okay.
Um,
Are you converting?
yeah, so I'm just
5 inches?
Sorry.
Centimeters?
sorry. Well, so here, let me just finish right and I'll explain what's happening here. So what I did was I took, so these are in inches, right? But if you remember, the only measurement we know is that 1,000 cubic centimeters is the same thing as a liter. We don't know what that's like for inches.
Well, some people would not be using much.
Well, don't show up to class on over. That's the answer here. So I know that 1 inch is the same thing as 2.5%. I'm just going to write that in here a little bit. So 1 inch equals, it's the same thing as 2.54 like centimeters. So all I'm doing is I'm converting 2, 3, 4, 5. So all I'm doing is I'm converting all of these inches into centimeters, right? Like if you remember, like you guys have a ruler, right? Like these things, like the rulers that you have, it's 12 inches or 30 centimeters. All you're doing.
207.4 or 207.
I will get there. I will get there. So yeah, so all I did was I converted these and then I multiply them. So yeah, so then you're going to end up getting 207.39 centimeters cubed. So
I don't understand that, why if it's 39.8 or 34.8, it's 3.1. So now it's like 398, so wouldn't it just be 207.4?
207
Because
decimal.
they're all high numbers.
Oh yeah, you're right. That one would be, yeah, 2 point. Yeah, you technically could say that's also 0.4 there. That's fine too. You're right. You're right with that one. But so
Because math wouldn't even be, like, you can do all those decimals, but they're always like, if it's 5 and up, it's a number higher, right? But then if it's like these high numbers, or what is the right answer?
So I just, you're right. It is the 0.4 there. Yeah. I just made a mistake with that. So what I want to talk about though is the inches cubed versus the centimeters cubed here. So like you can see that this is technically, these are different, like they're completely different, right? They're completely different in
Oh, shit. Sorry.
yeah, I'm just trying to explain the concept and you keep interrupting.
Well, why teach us math and then get it wrong?
I was trying to show a point. It's the base units matter here. So we the reason we had to convert this into centimeters was because the question's asking us the volume and the capacity, right? And we need to go to the metric system. We need to go to those centimeters in order to be able to use to convert that capacity into the liters. So now I know in this case, my capacity in this case is, it's just this divided by 1,000 for the liters, right? So that's just going to be 0. I'm just going to put 2.1 liters there. All I did was I shortened that, or this is 207 milliliters. So I just wanted to kind of point that one out there. The base units do matter. So I actually want you to go to that page above. I actually want you to throw that in there. Like I said, you'll get this all in a formula sheet. later. But I just want you to go up to page 40. I just want you to put that like anywhere here and then like box it. So so 1 inch is the same thing as 2.54 centimeters.
Like the same as like a foot, isn't it?
Yeah, like one foot is like 12 inches, which is 30 centimeters, right? There's different units of measurement for like the same distance. And unfortunately, when you're given something in inches or something non-metric, it usually turns to a disaster, which is why eventually you pretty much always end up turning it back into metric. So just kind of powering down through here again. Cool, I'm just going to quickly power through the answers here. So I just want to know, so this is 2. So for question 3, I'm curious how people solved this one. Oh, okay. So
I found the volume of the first prism,
Mhm.
when I get all the dimensions up, and then I divided it by 14 centimeters and 20 centimeters to find the height.
okay, yeah.
And I don't know if that's correct, but it could work.
Yeah, well, so we'll go through that again. Like, so now we're in a complex problem. There's different ways of solving it. But so what I know is I have 2 prisms. I know the dimensions of 1. So I'm just going to quickly calculate that out. So 18 centimeters. So I'm just going to put, I'm just going to straight up put prism 1 is just, it's 18 times centimeters times 12 centimeters times 32 centimeters. Oh, I plus those 18 times 12 times 32. So this is just 6,912 centimeters cubed. So that's the first prism. That's the volume of it, right? The second prism, all I know is the base. I don't know what the height is. Now, you could use algebra to calculate this out, which we haven't learned yet. But we could also just kind of use like our logic with this, right? So I know prism 2 is the base, which is 14 centimeters times 20 centimeters. And there's just some unknown height here. There's some unknown height, but one thing I do know is that it has the same volume. So we could use algebra to figure this out, or we could just kind of like think about this. So here we go. So if I know that it has the same volume, remember, volume is just the base times the height. I'm just going to divide this by the base. I'm just going to write that to the right, actually. So if I divide this by the base.
Which base?
Ooh, good question. So it's the base of the second cylinder. That's a good question there. Sorry, not cylinder, the base of the second prism, because that's the thing I'm trying to figure out the height with, right? Yeah, so I'm going to divide this by the base in this case is just 14 times 20, right? Or you could also say 14 times 20 is 280, or it's 280.
So I could divide that by, I mean, 14 times 20.
So yeah, you could divide that by.
Your number right there, right? And then I could divide 6912 by that number. Okay.
Right, so that's technically what's happening. That's the base right now. For the sake of space, I'm going to remove these 14 centimeters times 20 centimeters. I'm removing this, and I'm replacing that with 280 centimeters squared. I'm dividing it by the area of the second of the area of the second prism's base. So that's why I got the squared there. But so what my final answer here is going to be, it's just 6,912 divided by that 280, which is just, that's the area of the base. That gives me 24.69 just centimeters. How come so how come I went from a cube to a square to just a basic area of measurement, a length? How come I did that?
All the way down.
Yeah, because this is technically just, this is the height, right? Right here. So the height can't be an area. The height cannot be a volume, a capacity. It needs to be a length. So what I did was I knew that I knew the volume of it, and I know I get the volume by doing base times height. So if I don't know the height, I can divide it by its base instead to figure that one out. Gives me the answer. And that I end up getting the height there. So just pay attention again. These last two questions were kind of meant to like guide you on. It's important to pay attention to the type of measurement, inches, centimeters, meters. It's also important to pay attention to this little like exponent unit there, like the cube, the square, if it's singular, stuff like that. All of those play a different factor. And then for question 4 here, so this one's just like a word problem, right? So I have a hole that is, so the volume of the hole is 35 meters times 25 meters times 12 meters. 35 times 25 times 12 is 10,500 meters, right? And so this is some stuff that, like, if anyone here's ever like, you ever seen like those highway trucks driving by? Department of Highways. This is the stuff they have to do every single day. They literally have to like, they know how much it costs like for fuel to go pick stuff up or to go deposit it. So they work out their budgets this way. I used to work for the Department of Highways, actually. I was the guy who did the sign. I was the flag person. I almost got hit by a car probably every 3 days. People are on their phones way too much when they drive. So to figure this question out, so she's in charge of excavation for a foundation of a building. I have a big hole here. Let's figure out how much the volume of that hole. I want to know how many trips it takes to remove the dirt from this. And this trailer can only take 15 cubic meters of dirt. So all I need to do in this case is I know this is how much cubic meters of dirt I have. I need to divide it by how much dirt I can take per trip. By 15, yeah, this one's just by 15. 700. Takes 700 trips. That's it. Okay. So what I want you to kind of go to now is just kind of keep carrying on through here. You can ignore page 43. Don't worry about that one. So you can ignore page 43. And you can just keep on working here through page 44 onwards. 44 onwards, you betcha.
Oh, I never said onward.
Oh, no, I kind of stuttered there or no, I didn't stutter. I slurred there for a bit, actually. So I rely on you, Kim, to like catch me for all my grammar like mistakes. It's actually been pretty good for me, to be honest with you. I used to be in Toastmasters and I'm not anymore, so it's nice to have that catch there.
So from page 44?
From page 44, you betcha.
I'm sorry, you're just supposed to be like, thank you, Nazi drummer or drummer Nazi.
No, oh no, I appreciate it. It's fine. I like it. Yeah, so you guys get the rest of the time here to work on this stuff. And if you finish that, you can go back to that surface area questions because there was a lot there and some of them got pretty complicated. I'll be posting the answers here for that during the break.
Everything.
For everything on this unit, yes, including the one we're doing tomorrow. So don't peek.